All right, so thank you for joining, everybody. We'll give everybody a second to keep on joining. Today, we're joined by Dr. Jeff Ho, who's a technical product manager here at Safegraph. He'll walk through our patterns data set, which he actually curates specifically for businesses to learn more about consumer interactions with places. And it can be used to inform business strategies like site selection and investment research. This webinar will be recorded and will be available on demand. So afterwards, if you'd like to share it to colleagues or whomever, you'll be able to do so. Just a reminder, you can also use the Q&A functionality, which is in the bottom of the screen. Feel free to use that throughout the whole session, and we'll answer the questions at the end. And so with that, I'll kick it off to Jeff.
Great. Thanks, Annalise. Super excited to be able to be here with you all for the next sort of half an hour or so, maybe 40 minutes, depending on how long and how fast I talk. Really, I'm sharing my screen, right? Annalise, that's right. People can see my screen.
Yes.
Okay, great. So yeah, as Annalise said, my role at SafeGraph here is as the technical product manager for our patterns data product. So our foot traffic aggregated to places and aggregated to neighborhoods. So a bit about me. I have a PhD working largely at large volumes of geospatial data. After that, I moved into industry, became a data scientist, primarily working in advertising at first, but then I also worked in humanitarian disaster relief as well. As in advertising, that's where I first got exposed to running campaigns for clients, primarily in CPG and the financial services sector. And then really was able to leverage this sort of passion and love for geospatial data and machine learning models into sort of real world applications for businesses, for understanding different marketing efforts and so on and so forth. Since then, ever since I've joined SafeGraph, now my role in shepherding the patterns product is really about managing our pipelines. So working to make the best quality data for use in production ready models for data scientists who work in all sorts of different fields. So government, in large multinational corporations, to startups working in AI and sort of the competitive space there. So really excited to introduce you to the patterns data. I'm going to be walking through SafeGraph as a whole here. Which I just move forward here. Yeah, so I'm going to be first walking through SafeGraph as a whole, brief summary of who we are. If you're new to this, if you're familiar, hopefully you learn a few new things about SafeGraph and who we are as a company, what our main focuses are. Then I'm going to jump into a technical deep dive onto our patterns product. It's a surprisingly complex, basically machine learning pipeline with sort of several different steps, taking raw data, aggregating, processing sort of large, outputting into a flat CSV file that get either delivered to enterprise customers or are available in our self-serve delivery option on Shop. So lots of interesting technical machine learning questions. Happy to talk about that there. And then I think the bulk of the time I'll spend jumping into number 3 here, which is our use cases for patterns. So one benefit that I have being the product manager for patterns is that I'm on a call and I get to be aware and learn about all of the unique and fascinating use cases that customers use our patterns data for. Frankly, it's actually one of the best parts of my jobs, really just thinking about all the different ways people use our data, from understanding cash flow in the economy to leveraging and understanding how campaign data can be used to understand the effectiveness of advertising campaigns, to helping to understand the spread of COVID and thinking about how vaccination sites can be rolled out. Really broad use of data, and frankly, the most diverse in terms of any types of product that I've ever worked on before. So really excited to jump in there and to talk to you about some of the use cases for foot traffic data. The reason we structured it this way is help, even if you're really new to SafeGraph or you're come to SafeGraph with lots of expertise, I'm hoping you learn something new about today, whether it's about SafeGraph, it's about our patterns pipeline in particular, or it's about the different use cases that our data can be used for. And we find that with foot traffic data product like patterns, really there's a need to sort of stimulate one's imagination about what things can be done and what the data are good and are not good for. And so that's something I hope you come away with today. And then lastly, there's a Q&A section here. So if you have questions, feel free to type them in the chat. I'll be monitoring as we go along. So I can answer them live, but we'll also have time at the end to answer questions as well. So if there's, feel free to jump that in, chime in, if that makes sense. If there's anything you wish for me to cover. But other than that, you have me for the next little bit. And so I'm gonna dive in. Okay, so SafeGraph at a glance. As you may or may not know, SafeGraph is a company that's focused primarily on providing information vis-a-vis data on physical locations in the world. So we are a pure data company. So what we provide is can be thought of as tables of rows and columns. And each row in our places data set, which encompasses several different types of columns, is something we call a point of interest, a POI. And in our data set as of today, we have about 10 million points of interest across the US, Canada, and Great Britain. So that's in the top left. So 10 million places on which you can find information in the world. We also have a classification system for understanding what those types of points of interest are. We use something called the NAICS category, which gets to the level of granularity of, is this a certain type of fast food restaurant? Is this an industrial warehouse? Is this what's another type? Is this a transit station, right? So we have these different types of classifications that leverage this well-known classification system for understanding and filtering the types of points of interest in our data set. Another way in which you can think of the types of data that we have is if it's for certain businesses. So businesses which are multi-location are a classification we call brands. So sometimes this is called chains, or sometimes this is called chains is a good one. So think of McDonald's, think of Starbucks, think of large chains like that, which have sort of thousands or tens of thousands of locations. But even for small chains or small brands that may only have 3 locations in New York City, a pizza place which has done well in several different boroughs, for example, those are the types of brands that we track and allow you to filter on and help you perform aggregations on our POI data. So if you think of POI as rows, now we're thinking we're going across the table to think about different columns of our data set. One of the things we provide for the points of interest we have in our data set are geometric shapes, which are represented as polygons in our data set. So if you've ever worked with spatial data or location data, these are vector columns which represent the polygon in that can be mapped in a particular mapping application, for example. So we find there's a lot of really strong use cases there, both for mapping, but also for understanding things like square footage and how many businesses exist in a particular building footprint, for example. And the polygons aren't limited just to large building footprints. There are things where there are places where, for example, if you're looking at a strip mall, you'll be able to see the building itself is sort of one large building footprint, but we'll segment out those different businesses in the polygon to see the different forefronts of, let's say, the laundromat and then the taekwondo studio and so on and so forth. So the polygon data set is a particular enriching column for our point of interest data. We've also expanded. SafeGraph grew primarily, as I said, in US, Canada, and Great Britain, but we've expanded a portion of the columns to 188 countries globally. This is part of our newest global brands data set. So focusing on branded POIs, core information about them, like their address, when they opened and when they closed, across 188 different countries around the world. So if you're interested in, for example, if certain hotel chains are expanding in Latin America versus other types, that's the kind of insight we wish to enable. And of course, with all that, you can imagine that a lot of this work has been leveraged amongst a lot of different types of use cases, both by companies, but also in academia. So during the pandemic, we also made our data freely available to academics and government use cases. And our data has been used in over 250 academic research paper. So that's me as my history as an academic. I came to SafeGraph sort of through that understanding. So it's a great tool, I think, to understand how other people are using it and what the data are good and good not for, and not good for. So that was a lot. So if people have any questions, feel free to jump them into the chat. Okay, so those types of data sets, those types of insights are, as you may know, distilled into 4 distinct products that we're now focusing on at SafeGraph. It's the way to understand how we view the world through the lens of physical places. So we have our core places data set, which, as I mentioned, is available globally and has business listings for the 10 million, up to 10 million plus points of interest. We have our geometry data set. That's our polygon data. That's only available for the original 3 countries I listed. Then the topic of this talk is our patterns data set. So this is foot traffic data for the rows in our points of interest data, and that they're aggregated into 2 different products. So there's our places patterns data set. So that's for each row in the core data set. If we have foot traffic for that data set, for that point of interest, that's what we call a places pattern. So this particular Starbucks on 123 Main Street, what are the visitors this month? How busy is it on the time of day? Where do those people who visited this point of interest come from? These types of interest at the place level. We take that type of data is based off of aggregating anonymized mobile device GPS pings, which I'll talk about in the next few slides. But you can imagine the same types of aggregation, same large scale data processing can be used to aggregate those types of device pings to different shapes, basically different geometries. And so we also offer a census block group aggregated foot traffic data set called our neighborhoods patterns product. This is available in the US and Canada. And what this does is, rather than looking at all of the visits to the Starbucks at 123 Main Street, it looks at, let's say, the census block group for where I live in Brooklyn, all of the devices that came into this area, where do they come from? At different times of the day, where is it popular, where is it not? You can imagine this is useful when, if you're, let's say, a government thinking about mobility flows. This might also be interested if you're thinking about placing a business in where it doesn't have any points of interest yet. And so that's going to be the focus of this talk, looking at our places patterns and our neighborhood patterns data. Ooh, I see a question. Let me just pick it up here. Oh, it just says hi. Well, hello back. And if you want to ask more questions, please type it in. Okay, going on. So let's talk a little bit about data. So I talked to you a lot about like sort of high level, SafeGraph as a company. How do we think about the world? We just focus on data quality and data veracity is really important to us. So how does that manifest in our pipeline? How do we, one, create our point of interest database? How do we create our core and geo data? And so it sounds like a simple problem, just looking at business listing information for 10 million points of interest. But it's just I keep saying surprisingly complex, but it is a surprisingly complex kind of process. And so it starts by onboarding data from thousands of different and diverse sources. So this is what we call our ingest process. So bringing in these different points of interest, like a Starbucks in 123 Main Street may exist in several different types of listings, different types of suppliers. And then we have to work on deduplicating that data, cross-referencing it, and discarding bad data. Because we focus on selling our data to data scientists primarily, we know that bad data really leads to bad inference and bad prediction. And so this type of deduping and cross-referencing is like sort of really important to us. I also see a question here about foot traffic to shopping malls. I'm going to jump into that in the next slide when I talk about patterns. Let me just finish my conversation here about POIs. In the second point here, we have a draw service. So I talked about those polygons, having accurate polygons for the point of interest. And here, those are derived from satellite imagery, satellite image object detection kind of algorithms. As satellite images are really robust these days, and also the neural networks that detect building footprints from them are also quite robust. And so that's sort of the level of granularity we have them. We also just have, honest to goodness, hand-drawn polygons. So like we have a lot of sort of manual curation of those and updates, sort of blending the machine learning models with sort of human efforts. Of course, there's some complex merging to associate these different sources of data. Again, also leveraging machine learning and also human feedback about sort of accuracy and about our sort of different data sets. Then, as I mentioned before, we had that classification system of the different POIs. So we have an algorithm that classifies different brands and also denotes spatial hierarchy. So if you have a POI that's in a mall or in a strip mall or so on and so forth, those types of hierarchies need to be applied. We have verification here as well. So like there's obviously truth sets involved, some QA processing, unsupervised classification to sort of unearth anomalies. And then repetition, right? So like you just get very good at doing this, growing from data sets that were in the millions, now tens of millions. And so it's definitely one of our strongest competitive moats here to expand this sort of pipeline at a large scale, effectively and efficiently. Oh, so I see another question here about POIs limited. Are POIs limited to businesses, or could you look at something like foot traffic visits to a church or a venue? That's a very good question. We do have sort of non-business points of interest in our data set, things like parks. I think churches are in there as well as schools, I believe. But one of the important things that we do here when we aggregate the information up is that we make sure to anonymize and add noise as basically a filter for privacy for these types of points of interest. So having the points of interest here are useful, for example, when let's say someone wants to invest in some real estate, but they don't want to be too close to certain other types. They don't want to disrupt traffic for a school or so on and so forth. So like knowing that those are nearby are very useful. And then we take a lot of really strong care to make sure that privacy is applied sort of when we have foot traffic for these types of places. Okay, so this slide I was talking about how we create our point of interest database, our core and geometry data. And the reason that's important for the patterns data is because these are both input data sets into our patterns model. So what happens here is that we have these anonymized GPS pings, which can show up in this toy representation here, where you have sort of different pings, sort of with different timestamps. And it can be a little tricky to figure out where these types of pings, which locations they visited. So in this toy example, these red dots represent GPS pings, and then the different blue boxes represent potential places, business listings or parks or different types of places that the GPS pings, the devices could have actually been visiting. And so what we've built is a proprietary learning to rank model. Well, sorry, let me take a step back. First of all, you would have to do a lot of cleaning of the GPS data. So there's a lot of, there are issues of horizontal accuracy where the phone's knowledge of your location is quite sparse, depending on cell signal, a number of factors. So we do those types of filtering. There's a lot of sort of just false data in it that we make sure to filter out. So if a GPS ping is in New York and then suddenly in San Francisco, those tend to be inaccurate, and those are actually fairly straightforward. But there is the problem of the volume of data. So what we do is also apply a clustering algorithm to group close in time and distance pings into clusters using dbScan, a time-based application of dbScan. And then those clusters are what we do to assign visits to different types of places. And it tends to be pretty conservative because we'd rather not assign a visit than do. And then, so with those clusters, what we do is we have a learning to rank algorithm that's based off of a ground truth data set where the parameters are. And what that does is say, for a cluster of pings such as this, it'll take into consideration which of the locations A through F to be assigned to. And those are things based off of, geospatial features like distance, but also features like the NAICS code, the classification of the system, and the at time of day. So the logic behind that is that if there's a cluster of pings and it's like 10 p.m. on a Friday night, most likely that visit is going to be assigned to the bar nearby rather than, let's say, the library or something like that, right? So those type of relationships emerged from the model as we built it. Here's where I'm going to jump back to this anonymous attendee question about the SafeGraph intend to collect foot traffic for shopping malls. And so yes, we do. So we definitely track visits to the overall shopping mall structure. Thinking just about indoor shopping malls right now. But the challenge is within the shopping malls, the GPS accuracy is quite low. So it's very hard to know whether a phone is at the Auntie Anne's buying a pretzel or at the Gap buying the latest hoodie or something like that. Don't judge me on my random knowledge of mall things. So that's challenging. So we actually, rather than sort of provide some estimate or some inaccuracy, we're actually quite transparent there. And we only track visits sort of to the larger enclosing superstructure. Of course, things are different if it's an outdoor mall. I'm thinking of like the Stanford Shopping Center in Palo Alto is where I spent a lot of time before. Those type of outdoor structures where the device pings can be tracked more accurately. Those will be more accurate, but these shopping mall behaviors tend to be a little challenging. And that similar question applies for the second question. Does the building footprint data include the Z height value and or the number of floors? So that's a good question. As of now, it does not. We had that column before, but the fill rate was quite low. And we basically ultimately decided that having inaccurate data was worse than having sort of partially sort of questionable data. And so we ended up nulling out that column. But that said, sort of our patterns foot traffic algorithm still can incorporate accurately assess visits between floors because of those things like I described, the features in the model, the NAICS and hour, for example. So if a bar is on top of, I don't want to say library because bars would never be on top of libraries, but if a bar was on top of a library, even though we have no Z dimension, our model will figure that out based off of our check-in data. So that's a good question. It is an important limitation of the data. I would say if you really have to track visits to a very tall superstructure, the data are going to be more challenging. But that's something we make available and we work with you on good and less good uses of our data. Good question. Really appreciate them. Okay, so I mentioned here the pipeline for our patterns data set. You can understand here now why we're so fanatical about our core and geo quality, because they directly impact the quality of our visit data. If you have bad polygons, you're really just tracking, you're inaccurate by sort of many meters, or you just have like a point and a radius, you're going to get inaccurate visit attribution data. And so that's really important for us. Here's just a slide really thinking about the vast applications of our location data. So we really like to say at SafeGraph that everything has a location, everything has a geography, and the location insights that are made possible through SafeGraph data have a surprisingly wide range of applications, from retail, real estate, and logistics. So places, things where, let's say location is like part and parcel with the type of analysis that are being done. So like individual business forecasting, maybe aggregated store forecasting. Think about trade areas, like how far do people travel to my store to buy things? If I want to sell products at these stores, how far will people travel to these particular types of stores? And then site selection, right? So say you're a manager of a brand that has thousands of locations, you want to constrict during the pandemic, right? Like which of the sites do I want to remove? And if I'm trying to expand, which are the areas do I want to go in? So obviously those types of applications where location is critical to the use case, we play a big part in. I think we've had a lot of success in those types of use cases. Moving on to sort of the type of industry that I worked in before, marketing and advertising. We actually have a lot of use cases here as well. I think a lot of people who think of modern digital marketing and advertising think about digital marketing, being able to track individual users to and then see whether they purchase online or not. But because of the importance of retail, pandemic notwithstanding, I think the importance of understanding location with respect to retail has continued to be important, and we've seen strong applications there. So not tracking any individuals, because one, we don't have that information, but two, we don't surface any of that in any of our products. We just have locations. But using that data to understand things like visit attribution, so using our really high accurate polygons for other people who have individual data to understand if someone saw an ad online for Coach and then they went to a Coach store, for example, is really important. Thinking about location-based advertising. So coming from my background, I know that when you try to target people for advertising, it's really expensive. The more and more information you can try to know about them, which is why Facebook and Google and so on and so forth make so much money. But there's also a way to have location-based advertising. So if you nearby a certain type of store, I know when I'm in the vicinity of a Starbucks, I often get ads for Starbucks, and I like Starbucks, so it sometimes motivates my attention. Although maybe I'm just making that excuse because I really actually just like pumpkin spice lattes. But location-based advertising, I think, is an important part of it. And of course, out of home. So like billboards, digital billboards that we have in New York City, that sort of stuff, I think, as well. I have some very interesting questions here about technical questions and the white paper. Let me finish this slide. I'll go back. Really happy to answer this question. Okay, given time, I might actually focus ahead a little bit, but I want to make sure to get to this question. Thanks for your question, Robert. Okay, so then the last application sort of we've seen more broadly is with financial services. So you can imagine once we're tracking foot traffic to different types of stores and different types of brands, there's a lot of really interesting insights that can be gleaned in the financial services space, whether it's investors in specific companies, thinking about where are they growing and expanding, how much is their foot traffic changing, what are their strategies, are they working, are they not, and then of course people who make plays on the market, and also the insurance sector. So thinking about co-tenancy, like which locations are located near, let's say, other risky areas. Let's say that library underneath the bar. Maybe that's a little more risk than a library in a different type of section. Lots of different types of interesting use cases that I'm then going to jump into as well. There is a technical question here about clustering, which I'll cover at the end. Thanks, Robert. Cool. Okay, so I talked a lot about who SafeGraph is, how we think about data, how our different products work together to make our patterns data set, and why we have this sort of focus on data quality, or at the very least data transparency, where we think data quality can be lacking. I'm going to focus on 3 broad groups of use cases here, and each will be represented by a different graphic that'll show up on the screen. One of the core use cases for patterns data is consumer research, which allows for insights about the movement of people and inferences about their demographics. Each of these, as I said, vignettes is a use case for how customers or the public have used our data. On the left here, this is a plot from a case study we did with our partner Spatial AI. And what they did here is look at customer segmentation for DIY, do-it-yourself trends that emerged during the pandemic. If you recall that time, in the dark time of 2020, lots of folks were, at least in sort of my social circles, were going out and making renovations to their homes, going to places like Home Depot or Menards in this case. And so one of the columns we have in our patterns data set is looking at something called visitor home CVG. So of the device Menards, where is their most common nighttime location or home location? And so we use this to infer what the demographics of these people might be, and of course, how far they've come from. We store the home location in a pretty granular level, geohash7. So we don't know enough about that person's actual location, but it provides enough information and granularity here to start to understand where the visitors might be. And so we provided this raw data. Spatial AI also provided information about census block group levels. And this particular analysis found out that these new visitors to these Home Depots and these Menards, these like people who started working on their homes during the pandemic, the question was, are they new customers? Are they current customers? What can we understand about who they are such that we can make sure they're consistent customers? And so this particular analysis found that the locations from which the visitors visited Home Depot and Menards did skew more liberal and younger. So maybe it's someone a lot like the sort of attendees on this call, perhaps, if you're sort of a younger data analyst or you're, in a certain demographic. And that was sort of the insight that, came out from this type of analysis, just buttressed by Safegraph data. So really interesting things, not just like visits to a point of interest, but thinking about mobility and demographics inferred from other sources more broadly. Looking at the top right here, this is just a quote from our customer information insights. They use Safegraph to understand which regions were coming back fastest during the pandemic, when other sources of data were far slower, and Safegraph patterns data, which is available on a weekly cadence at its fastest, allowed them to be much more nimble. As you imagine, things were changing more quickly, especially in the digital media landscape. So thinking about their customers, we're working digital media, think about loyalty programs, think about digital ordering apps. That weekly cadence of Safegraph patterns data really allowed them to move a lot more nimbly. This is really common, I think, to, so this is really common, I think, use case. This like faster cadence than, let's say, business information, like a business registry data or so on and so forth. On the bottom right here, this is another application I've seen of patterns data applied to consumer research. So not just where people are coming from, but being able to act nimbly on insights, but connecting data with other types of auxiliary data. So for example, people really often use foot traffic as an indicator of sales data. So thinking about how well different stores are performing, just using foot traffic as a proxy. So other things such as who buys things. So this is a plot showing indexed foot traffic data, so raw visit counts from our patterns data set versus number of transactions at a particular Whole Foods store since 2018. And you can see here that the foot traffic data track it very well. We've also tracked sort of a drop due to COVID, and then the fact that transactions really have not come back since the pandemic at this particular store. This is a really common use case where where customers will have their own data and they'll use foot traffic data and compare it to their own data and see, okay, well, we trust this data because it sort of directionally matches the trend the trends that we're seeing, or has a high correlation with it. And then they go ahead and they use patterns data on their competitors. Okay, well, this is how our stores are performing in Safegraph data. Here is how our competitors' stores are performing. So that kind of insight is really useful, and especially if it happens at the cadence that can happen here. The thing all these three have in common is this newfound ability to make decisions based off of intelligence from foot traffic, and then to make decisions based off of either targeting strategy, out-of-home placement, or store sales. I'd say the other core use of patterns, as I'd say, is for site selection. It's really common to score different retail points of interest based off of a variety of factors. And again, it's not retail, as someone mentioned, like we have other points of interest like parks. We have a parks department using our data to understand why certain people go into certain parks or not, and whether or not they should beef up services at some parks versus others. But the site scoring is super important. On the left here, in this example with our partners at American Securities, using the patterns, again, visitor home CVG data, looking to score sites for just that. Rather than looking at change, as in the Home Depot Menards example, what they're doing here is to look at different stores and then scoring them based off of the demographics of the area, how sales are doing, who are the nearby competitors, who are the customers coming to the store. All of that is built into a scoring metric for ranking sites. And we find a lot of people who have a lot of useful applications with own domain knowledge, whether in retail or real estate, with sort of the raw data signal they're getting from Safegraph. So we love those type of partnerships because it leverages your own data science and domain expertise and our fanaticism about quality data. In our top right here, our customer Volta applies a similar problem for expanding the locations of their EV charging stations. The scale of Safegraph data really helped them here. So having data across the US and Canada, really thinking about as they entered new markets on which to place their EV charging stations, like what were the benefits to surrounding businesses? Did foot traffic at surrounding businesses go up because of this new amenity, which is an EV charging station? And then, as I mentioned before, coming back from the pandemic, I think is really important, as has been an important use of our patterns data. In the bottom right, not an example for any particular customer, but thinking about how time series information can be used for site selection. So similarly as the site selection criteria, you can use trends to inform a site selection criteria. So like maybe foot traffic is low now, but foot traffic has been trending a lot. So like this is actually in the forecasting sense, a place that makes a bet on future trends go in the same direction. Okay, so I'm going to say the last question here, then answer some questions. I'd say the last application here, a really common use of patterns data. Patterns data really is not just reserved for analysts generating insights or data scientists building scoring models. What we've seen is a growing number of use cases that just take the raw data and then use it as a means of enhancing an existing application in which they have. So on the left here is a really fun one. It's a crowd-free app built by TripAdvisor and some other colleagues. What they did is, during navigating the pandemic, trying to avoid crowds as much as possible. So actually, unlike most use cases, what they use is the popularity by hour column, which is an aggregation of device visits to points of interest. And they applied it across the US to build this app to determine when places were likely to have the smallest crowd, so the least popularity, as a way to avoid crowds sort of during the peak of the unvaccinated time of the pandemic. So I thought that was really interesting. And like, so that's just visualized and then shown here, not really any model per se, but really, I think people don't think about this as a use case of patterns per se, but it's been a really growing and interesting one. And on the right here, your friend of mine, the visitor home CBG column, this is used sort of in an application for trade area analysis. We've seen a lot of people who have sort of dashboards that represent different stores, and they maybe will have some sort of distance metric like, okay, people are probably only going 20 minutes to the store, and they build a little visualization. We've seen that work, but really, I think we've seen a lot of value from this visitor home CBG column, not thinking about demographics of where they come from or the scoring, but thinking about just literally where they come from. So I think this particular map shows Costco's in the Bay Area, and then looking at how far and how many people come from those census block groups people visit. So especially useful for those types of visualizations for the long tails, like people come from far away to this point of interest are kind of the point. I can think of an example where there's like a grocery store that people will come a long distance from, maybe an ethnic grocery store, and then that's really useful. And it's not just, you can't make the assumption that people just come from close by. And we're increasingly working with customers who are building application layers on top of SafeGraph data to enhance capabilities and insight generating capabilities for their customers, really not just the end user, but sort of middle layers as well. All right. You out of saliva as well? Maybe just me. Okay, so happy to open up to the different types of QA. I see a few as well. Happy to jump into them. Apologies, Robert, I'm going to answer this anonymous question first because it's a little shorter. How do you estimate total visitor counts from a small mobile visit count sample? If I understand the question right, it's about estimating, let's say, the real visits from our sample. So I should have mentioned that patterns data, our foot traffic data, comes from aggregated GPS, aggregated mobile devices, but the devices that we have in our panel are a subset of all devices that exist in the US. So it's a sample, and then it becomes a sampling problem, as in other types of applications. So one thing we do is surface for every day that we provide data, something called normalization statistics. So it's about the size of our panel by geographic region. And this, what we do, we leverage this to normalize our raw visit counts and upsample based off of the sampling that we've seen. Sampling rates vary by state, by census block group, by point of interest. And so we found a lot of good success for people assuming that visitors who come from a certain place maybe are over or under sampled, and then upsampling visits from those individual places. That's one way in which normalization occurs. I will say that, like, when people try to estimate true visit count, we often see that that's not exactly what people need. People need to see trends. People need to compare data between points of interest. And we find our data are best used for those types of use cases So our panel doesn't change too much over time. And so the panel variation between points of interest is not as large as you might expect. It's not very large at all. And so those types of comparisons across geography or across time tend to be our best bet. If you're looking to get an exact number of people who visited this Starbucks at 123 Main Street, I think you're going to have a hard time, even though there are people and companies who are doing this. It's just something we don't feel comfortable with, given the inaccuracy and the black box modeling need to do that. So happy to work with you on your particular use case, but we tend to provide the raw data to people and then work with them to figure out how they can estimate up using sort of their own domain knowledge, right? Like no one upsampling technique, I think, that we could apply would apply to all the different unique use cases that we have. But great question. Okay. Okay, let me jump into Robert's question here. Thank you for bringing up this white paper, first of all. So all of the visit attribution. So let me just read Robert's question. I read the white paper, Determining Points of Interest Visits from Location Data, a technical guide to visit attribution. Aside, this is our publicly available white paper on all the things I described. So the clustering algorithm, the learning to rank algorithm, how it works. Go to our website if you've forgotten everything that I said, because it's very useful and very detailed. I highly recommend it. Robert asks here, I didn't want to ask too technical question that takes you back one slide, but while you're here and the coffee is apparently still live in your system, appreciate the energy. I'll give it a shot. It actually based on the cartoon image in the white paper, which it looks a little different than here. If you clean and cluster pings as a timestamp sequence of activity, and then had at your disposal highly accurate polygons, then the white paper makes sense that you just count the number of points that intersect the point of interest. But it's not that simple. So actually, yeah, so this is a good question. It's actually, we actually found, the white paper actually goes through this, just looking at points that intersect the polygon is a little inaccurate, actually, especially when you have spatial hierarchy, you have polygons on top of one another, and it's actually surprisingly challenging. That's why we ended up building this learning to rank algorithm, because of the inaccuracy of GPS pings and the fact that you need some truth set to kind of learn how pings can be assigned. We found that just doing a spatial join from polygons to lat longs, it works, I think, for a lot of cases, but for the edge cases, I think it really breaks down. And so the white paper goes into this more detail. I'm happy to talk more about this offline. I'll also give a plug here for our SafeGraph community. So we have I think it's over 10,000, 12,000, many people strong Slack community and web discourse community that goes into details about these sort of technical applications. You don't write 250 academic publications without having academics question your details a little bit. So if you have questions about our algorithms or about our data, how to use it, and so on and so forth, I encourage you to join our SafeGraph community. Search clustering, search my name. You'll see a lot of people who use this types of data and have these types of questions that we've talked about before. I'm going to Robert's second question here. Lastly, is the pairwise comparison in Lambda Mart intended to only compare one cluster of activity with many possible points of interest, or can it compare a cluster of activity with many similar clusters of activity in order to compare if they similarly get matched to the same point of interest? This is a very good question. Just so other people are aware, what this means is that for each cluster of GPS pings, what we do is provide a list of what we call possible places. And this is like, say, location A, B, C, D, E, F. Let's say this cluster, like there's cluster 1 here, and then there's 6 possible locations here. So our pairwise comparison here really is intended to compare this one cluster with these 6 locations and figure out which of these 6 should be assigned to this one cluster. Thus far, we have not specifically worked with a lot of like comparing those that 1 to 6 vector to well, it's not 1 to 6 vector because it's each 1 to 1, but we haven't looked at comparing, like doing some sort of similarity or unsupervised classification on other cluster location pairings, primarily because the features are so geographic in nature. So like some of the main features in the model as described in the white paper are distance to the polygon, distance to the centroid of the polygon. And so we probably could do what you're saying, if I understand it right, Robert, but I would be thinking quite critically about what benefit that would give us? I guess it could tell you about similar clusters and what they got assigned, but the ranking algorithm works pretty well. I had to think about that a little more. That's a great question to pose to the community and see if other people have thoughts. But a priori, I don't think I have a deep answer, and I'm trying to understand a little better. So we can take that offline. Okay, wow, that was a lot. I see Annalise is
Awesome.
back.
Yes, I'm back. Thank you so much, Jeff. That was great. We're right up on time, and thank you to everybody participating with all the questions. As Jeff mentioned before, you can visit our website. It's a great resource for getting more information, and the community is as well. You can find more information about the community at safegraph.com. But thank you again, Jeff. And yeah, everybody have a great day. Thanks for joining.